So when we want to solve the equation, in the first step, we need to solve one of the equations for x or y. Doesn't matter which. And sometimes step 1 will already have happened and you don't have to do step 1 because it's already solved for a variable. And then we will substitute this expression into the other equation and solve for the variable. Then we're going to, after we've done that, we're going to substitute your answer into the revised equation from step 1 and solve for the other variable. And it doesn't honestly have to be the revised equation. You could put it into whichever equation you want. So if the x or y is already by itself, personally, that's the only time I use substitution. Is if something is by itself, it's set up nicely to do substitution. In number 1, this example, both of these are solved for y. So I can solve them by substituting. I can put this where this y is. Because if y is equal to that, it can replace it. Or for instance, if I said, I am as tall as Nisa. And then I also said, I am as tall as Amanda. Then you know that Nisa and Amanda also must be the same height. So if y is equal to this stuff, and y is also equal to this other stuff, this other expression, those two expressions are equal to each other. Are we really adding the like terms? Like we gotta, yeah, we're gonna have to move it over. Yeah, exactly. So there's no 6x. We'd have to move the x over. And you could do that more mentally instead of writing it. But it is 2x, not 6x, because the equal sign was between them. We just carry on until we solve this equation. So I'm going to add 1 and divide by 2. And we get x is -2. So step 1 was done for us in this case. Step 2, that's when we set up our equation that then has no y's, it only has x's. And we have solved for x. Now we're going to take that answer for x and plug it into either one of the equations. So now if I say y is equal to 4 times, and I'm going to put -2 there because that's what I just found out x is equal to, -1. So 4 times -2, -8, -1, y is -9. And then we give our answer as an ordered pair. What would be an appropriate way to check the answer? Well, both numbers plug it into the second equation, right? So we found -9 by putting our -2 into the top equation. But those two numbers need to make the second one true also. So if I do 2 times -2, I get -4 minus 5 is also -9. And that's my, pat myself on the back, I did the right thing. So I'm good. It's a system, so we're always going to need x and y, don't just stop after you get the first one. And in this case, getting the second one, you could probably pretty much do mentally to get the -9. so that one, the first one, we had both of them solved for y. We don't have to have both of them solved for a variable. It can just be one of them. So in this case, it says y is equal to 6x. So we can take that 6x and it is going to replace, it's going to substitute in to the second equation. So now the second equation becomes 2x plus 3 times 6x is equal to negative 20. So I have 2x plus 18x is negative 20. So 20. This time it is combined like terms, right? Because they're on the same side of the equal sign, which is good because we want this to divide nicely. We want it to play nice here. So I end up with negative 1 for x. And you could replace, you could put the x in either equation, but it's going to be easiest in that top one. Because 6 times negative 1, okay, y is negative 6. So negative 1, negative 6. And then just to prove to myself that it worked, I'm going to put x and y in the second equation. Negative 2 minus 18. Yes, it does work. Okay? So you can plug your answers in. If you're checking it, don't use the same equation you just used to find y. Use the other one. So in that case, when we substitute it, then we just did 3 times 6x. And it was just 18x because it was 6x, not 6 plus x. The next one we're going to have to distribute. And it's going to be really important that we've used parentheses when we plug it in. So this entire x plus 9 is going to go right inside where the y is. So now I have 3x plus 8y, but y is getting replaced with x plus 9. So where the y was, I've replaced it, but I need it to be that whole thing getting multiplied by 8, so that's why it's in parentheses. So now, way back from week 1, what do we do to start solving this problem? Yep. So we got to get rid of those parentheses. We can't do x plus 9, so we have to distribute. So 8 times x and 8 times 9. Then we're going to combine the like terms. They are on the same side of the equal, so do not subtract them. Actually add them together. Then we're to that nice two-step equation where we'll subtract 72 and then divide by 11. And I've got x is negative 7. So the easiest place to find y would be negative 7 plus 9. So then y is 2. So negative 7 and 2. And then if I am to check, if I want to make sure that my answer is right, I'm going to do 3 times negative 7. That's negative 21. Plus 8 times 2 is 16. And I can check and make sure that that does indeed equal negative 5. So that part is just checking that answer. Those first 3 problems, it was a y that started out isolated or by itself. In number 4, it is an x that's by itself. You do not need to move it around so that it's a y by itself. You would be working harder than necessary. But what does have to happen differently is now, when I plug this in, where is it going to go? By the 2, good, yeah, because x is what equals that stuff. If you accidentally put it in the wrong place and put it where the y is, then your equation will still have both variables. So if you start distributing and trying to solve an equation and you've used substitution and then you find out, wait a minute, I've still got x's and y's, probably you plugged into the wrong place. Because if I accidentally plug that in where the y is, well, then I would still have x's and y's. You should only, after you do substitution, now you should only have one variable. It could occur more than once, but you shouldn't have both x's and y's. So then distribute. And then even though those two variables, the 8y and the negative 6y, they are not next to each other, they are on the same side of the equal sign. So it really is 8 and negative 6. So 2y plus 14 is 12. Then we can take away the 14 and divide by 2. So then we get y is negative 1. So then when I want to find the x, I could plug that negative 1 into either equation, but the top one is going to be easier because I don't really need to solve, I just need to evaluate. So 4 times negative 1 plus 7. So negative 4 plus 7, x is 3. When you write your ordered pair, it is always x first. So even though, in this case, we found the y first, bless you, even though we found the y first, the ordered pair is always xy. So we still list the x first. Okay, so I'm going to show you one more example where we use substitution, but I'm going to be really honest with you that if this is the way the problem was presented to me, substitution would not be my go-to. Okay, so personally, I usually only use substitution if one of the variables starts out by itself. 5, 6, 7 here, they would not be bad to use substitution. 8, 9, they're still not bad. I guess none of these are ridiculous. But if you start to have to divide and you get like fractions, you really don't want to use substitution. So if one of the variables is not by itself and you are using substitution, you can get x or y by itself. You can use either one of the equations, but make your life easy. So in this case, it would make the most sense to use this top equation and get the y by itself, right? So if I get this y by itself, I just need to move x over, and now the y is by itself. Could I get the other y by itself? Well, yes, but then I'm dragging around -5/3 and -8. Like, ooh. And guys, by the way, that's one of the ways that I've been able to like know that someone was like using Mathway or something, because they've used substitution method when it is entirely ridiculous and no one would choose to use it if they actually knew what they were doing. So I can change this one into this easily, and then this can substitute in here. So then I have 5x plus 3 times -2x minus 2 is -8. And we're back to our whole distribute and combine like terms. And then add or subtract, in this case add, and then divide. So I got x is 2, and if x is 2, -2 times 2 is -4, minus 2, y is -6. Now I went through that quickly, and I hadn't done it ahead, so I'm personally just going to like double check myself by using that second equation. So 5 times 2 is 10. 3 times -6 is -18. And yes, 10 minus 18 would be -8. Now, you don't need to write this down, but I'm going to show you the same problem, and I'm going to choose this bottom one, and I'm going to get y by itself. It's going to be messy though. So I would have 3y is -5x minus 8. And then I would divide everything by 3, and I would get y is -5/3 x minus 8/3. Whew, that's just lovely, isn't it? So then I would need to plug that in to the top equation. So then I would have 2x plus this stuff. And so, yeah, there are online programs who, if you don't know when it starts asking, how do you want to solve? You might end up giving me work that looks like this, and I'm like, yeah, no, I just don't know that anyone's going to do that. But, you know, you can. 2x is the same as 6/3. So then when I combine like terms, this is just 1/3 x. And then when I add 8/3 to 2, let's see, 2 would be -6/3. So then I have 2/3. And then when I divide by 1/3 or multiply by 3, x is still 2. I come out with the same answer, but really, would any of you choose? I would hope, no. We would not choose to do the problem that way. So, can you get the same answer if you do everything correctly? Well, yeah, you can, but that's not what we would choose to do. Wouldn't be, it's not efficient to work with those numbers. So, on the assignment for substitution, because I'm going to show you another way that you might find much more effective for doing a lot of these other problems, I'm going to carefully select Or it may just be that I stop you early. These are all okay. As long as something is by itself, it's not bad. Yeah, just do 1 through 8. So just do the front side of the page. Okay, so on the front side of the page, the reason those are the ones I'm telling you to do is because they are written in a form where substitution method is your best bet. You don't have to do extra work to get something by itself. I do want to point out number 7 because we're going to have something interesting happen here. A couple things interesting happen actually. So I need to put this in for the y. So 2x minus, still use some parentheses so that you minus the whole thing. So then I've got 2x, this is like distributing a -1. So 2x minus 2x minus 1 is equal to 3. What happens with 2x minus 2x? This is gone, right? There are no x's. And then what's left says -1 is equal to 3. Is that true? No. So this would be no solution. Because if we would have put those two in slope-intercept form, we would also see their slopes are the same. And if their slopes are the same, they're parallel. If their slopes are the same and their b's are different. So if your variables, you substitute and then the other variable disappears, cancels out. If what is left is true, if that had said 3 equals 3, if what's left is true, you're going to say infinite solutions because really they're the same line. If what is left is not true, you would say no solution. If you still have x's or y's, if you still have variables, then you solve and you should get an ordered pair as an answer. So 7 is a special